Hi everyone, this is Elos and welcome to this video where we'll just do another round of naive solutions for the gauntlets. So there is a new gauntlet going on. It's a special gauntlet for me because it's the first gauntlet that is entirely made by one player, and I really want to put every tool in the hands of the players so they can do that type of stuff. So it's still not really there, but it helped me identify every single point I need to address to make those type of events completely automatic. So I'm really about that. I didn't really do a lot for this gauntlet, so I will try to go blind and try to do something based on the naive solution because I won't spoil anything. But I can show you what the naive implementation was. The naive meaning the subprocess score. So if we go to the website and we go to the gauntlet section, we can find the gauntlet listed here. So it's Open Community Gauntlet Visio, the very first occurrence, and we already have some player playing this, so it's really nice to see. And the naive solution is this one. It's because Hardship is an open-ended puzzle game, so you can have a lot of different solutions for the same problem. And because the score needs to be somehow reflective of the performance, but we don't know what the best is, and we need to have a fixed set of scores as a reference. So you have subprocess and process time, and subprocess is just the bare minimum you could do. Below that you won't change the score, because every time the first best solution is coming in, it becomes the new top, and it could happen also at the bottom, but of course the process is there to avoid that. So without further ado, let's do for this first week the 2-bit subtract. I hope I have nothing. Let's find, yes. So this is not a trivial schematic. I think we can make it work, and we'll see if I'm able to make that fast. Description, that's nice. I will just follow blindly the schematics, and I'll try to find tips and advice on how to play the game along the way. So first, what I see here is I need to have a lot of place. So I will just start by placing simply everything, and with a little bit of wiggle room so we can place without thinking too much of the wiring. I can remove the labels, so I can hit F8, the function key 8, and it will cycle through element of the interface. So it will hide the interface, and then the labels, and then everything, and then just one or the other. So you can have the combination you want to like be in a Zen mode, I don't know. And also every other shortcut works. So if you know your shortcut by heart, you can stay in this Zen mode. So no labels. We want one XOR I will just go really wild, and so there, and then so there, and then we need nuts. So a lot of players forgot about that, but you have those four buttons, sorry, that are the best. So every time you do a challenge and you succeed at it, you pass the validation. Bests are saved. So if you do a best with a nut, so validation, I don't have nuts, so I must have inverted instead. Yes. Oh, maybe you will hear the horn. I'm living in Canada and there is a lot of snow, and those trucks are there to announce that big trucks will go around to remove the snow. So sorry about that. So what I was saying is you can type any challenge you validated in this. So for example, I want an inverter, which is a node. And you can click one of those buttons to see the best blueprint you add, the best solution you add for that specific metric. So for example, if I remove the B, you'll see there is more, because those are not really challenges. But for example, I had this one, which is a weird shape. That was the last one I saved. Weird shape inverter. And if I take the best by block, I will have this one. And if I take by volume, will be this one as well. Tick will be this one, and most will be this one as well, because it's equal. But it can be slightly different with bigger gates or bigger components. So I kind of like the base, so I will just go with this. So let's go with that. So you have the undo redo, so I just Ctrl Z and start from there. So nut, we need a nut here, and so it's done for this stage. Now I need a end. Or a lot of ore. This, and that should do for the spacing. Maybe I will be slightly tight here, but let's go for this. And then I can just do another nut down there. Inverter instead. Let's try to stick to the general layout of the schematic. Let's go with an end, and then OR, and then inverter. So I have basically the layout of everything now. So I think you might want to know about is, you saw I just pasted everything, and I kind of remember the shape after playing Archie for so long. I know the shape of everything, and I know, like, for example, there is this standard that every input is on the left and every output is on the right, and then you have this layer which is always power, so it will be the 1, and then the one below it will be the 0, and then you have the logic that is below those two layers. But if you are not that used to see the shape of everything, you can typically have labels you can add. So for example, this one, you have labels that is inside this. So every time I paste this blueprint, you will see it puts an in label, so this is an input and this is not an input. So it's quite new actually. If you save a blueprint, you will have an option now that will include probes, which is really handy, because now you can have the input and the outputs and all the probes you can have. This feature is kind of interesting because at first I was pasting probes every time and it was like a mess after a while because you have so much probe and you use them only once just to block things out. So if you use blueprints, you can have them or not. When you use them in the challenge, you won't save the input output. But what you can do is use this new feature in blueprints chips. So you open the library and you have blueprints, you have the schematics where you can open all the schematics you already unlocked during the campaign, can be empty. But if you don't want to, if you want to have exactly one of your other chip without, having to deal with the blueprint and cleaning and all that, you just want a quick access to an old chip you add, you can just go for that tab here and it will show all your saves. So I have quite a lot because I'm doing a lot of testing, so those strange numbers are those testing. But if I'm going for the end challenge, for example, I can import that, and now I will have my end gate that is pasted here with every input and output and labels I add, probes I add on this level. So now I know how to plug these things. So I know this one is A, this one is B, and this one is the result. And the top two lines are always the power lines. So I can now plug this, for example, like so. So once more, if you want to L shape, you can just hold your click, and then while still holding left click, you can right click to change the L shape. And then now I just plugged my A input, and either you can just still use that for knowing values or whatever, or you can just remove it because now it's plugged. Can be cumbersome, but you have the choice if you want to do that. Me, for example, I know those two are A and B and the result of that, so don't do that. But if you are like pasting some schematics from someone on the internet, or like say for example, if we go to old gauntlets, not this one but maybe this one, we have best reveals and you have those really cool shaped components, but you don't did those yourself, so you don't know the pinout just perfectly. So you can just copy the image address, also the HD drive, and you can just go into the game and then go into the blueprint and import that. So it will try to load that from the clipboard. And so now I have my the blueprint from that other player, and if I paste it here, now I have all those labels, so I can just take a look at it and try to understand what that player did and how to plug things out, so it's really handy. And then when everything is done and I kind of understand how it's made, I can remove those things or just keep it there. Keep in mind that it can be really easy to paste a lot of things around and have a lot of props, so it's up to the player to do his own cleaning and whatnot. So this is a new change that was made not so long ago in the blueprint, but now if you use those options, you will export and import with props and labels and inputs, outputs attached. So with that out of the way, just need to plug things out, and it will be the second thing I want to cover in this video. I will remove those labels because I like to just work with what I have memorized, but I will try to still say that out loud so you can follow with me. So now I have everything roughly placed as in the blueprint, and I just want to go like blindly and wiring everything. So first, let's move those inputs A and B. Keep in mind that you can increase the space between those two pins by pressing plus and minus on your keyboard. And I will just try to get them as spaced out as possible. So there, and I need to have my first XOR gate like this, and then the second input will be the NOT. Let's go this way, and then the input will be that. So I won't plug the power lines just right now, but at some point I will have to do that. So now you see it will be quite the endeavor, and sometimes it can be, because I'm spreading things out really largely so we can see what's happening. But if you try to compact that, or if you try to place the gate in different position, you can, get a bit lost in all those traces because they are all gray. For that, what you can do is activate these colored segment feature. So it's in the toolbox, just here, and you can use that to activate the color mode. So the color segment got updated not so long ago. For that, it was not really handy to work with, but now it's better than ever. You can work with that, and what it will do, it will identify every contiguous trace, so metal trace with a color. So you can basically, this feature where sometimes I just click on a segment on a block, and I use this option, select segment, and this just selected everything on that segment. With that option, you can see all the segments as exactly the same. They are really happy about moving the snow. Sorry about that. So everything in this segment will be colored in pink, and that with all other segments. So it can be really handy. And if, for example, I need to plug this NOT gate out of this XOR gate. So this one is the NOT, this one is XOR. Those two lines are not in the same segment just yet, but if you connect them together, it will turn into the same color. So it can be really handy to identify something, what is connected to something. But keep in mind, sometimes color can be really close to each other. I still like this option from time to time to make sure this is connected properly and not to anything else. There is special colors, the red and the blue, so the constant power lines, they will be always red and always blue, like if you would run the simulation and you would actually see the state of every trace. So keep in mind that in those mods, if you do that, it will turn everything into the blue, which means in that instance it was properly connected, but it can be an error. So it's a nice and easy way to check that out. So let's continue to plug things out. I will have this in the bottom, spreading those out with the plus button on my keyboard, and then the carry out. So it's not that. I just need the carry to be somewhere at the bottom, and then A and B will be there. And I'll keep that far away from each other. Okay. So that's nice. We have this first layer laid out. You can have this plug also, so we'll reduce the number of colors. Sometimes I just like to do, when I don't want to think too much, I like to do that and just plug the power lines because it's so easy. Okay, so now the NAND gate, which is here, needs to have the A0 input, so this one. So this is another option. If you want to identify which pin is what, you can just hover on those buttons, so you can change the state of those inputs. But if you overlay on that button, the line will change into this yellow color to identify which one is which. So it can be also handy, because it can be really easy to mix sometimes the order of the pin. So we wanted to have A0, so I will try to keep things as tidy as possible. A0 here, and the node B is going there. So this is done for this A AND gate, and the input will go into that OR. Let's try to keep that somehow really distinct. And so the AND goes into that OR, and the other input for that OR gate is this XOR, so this way. And this go down in some other, so the XOR gates. So I'll go maybe not as far, like this, and then we have the top that is perfectly wired up. Okay, so what we can do is we can already test there. So we already have a minus B0 that should be working because it's completely wired up, and everything there is before that gate is plugged also, except the power line. So I will just do that right now because I want to do a really quick test. So let's wire that up. Okay, and then this. Oh my god, it's so ugly. Okay, I'll do that. I don't want to go too much into optimization because it's just it can go for a long time, and I want that to be really fast. So this is all dried up. So now we can do is you can bring the truth table, and you can just run this first step by clicking on it. So now all inputs are set, and the expected output is set to the first step. So what we need to have is the b r minus b must be equal to 3, or in binary 1 1, and we can see that this output is indeed 1 for the less significant bits. So the first test is working. Now we want the second test. There is this little bug I didn't fix, but I will. Now we want that to be 0, and it seems to work. 1, and then 0, and then 0 again. So that seems to work really well. So this is just a quick sanity check to make sure everything is properly connected together. With that, we can just continue with our wiring. So let's go with that. Color mode. Let's start now with this XOR gate. So now I want this XOR gate to be connected to A1. So A1 is this byte, and I'll go up just 1, and I will need to use B at some point. Now let's wire that straight away. A1 and B1 is plugged now. I still need to have A1 plugged to that end, and then B1 is only connected to NOT, and so I will just connect it to NOT B1. So that should do the trick. So those 3 gates are connected now. I can just go with XOR. So we have this output that must go into one of the input of the XOR, and the AND gate that is below. So let's plug that. So this is the AND gate. We have the 2 inputs of the XOR connected to the OR, which is good, and then the XOR connected to the XOR and also the AND at the below. We can connect this to the outputs, so that should do the trick. Now we want to plug the output of that AND here, and it must go to the OR. So I'll go there, and the AND that is here needs to be connected to this. Yeah, just below. There. Okay, so all gates should be connected now, and I just need to plug the OR that needs to be inverted, and this will be the carry. So we have everything laid out together. Now we'll just do the power line, so it's quite easy. Those lines must turn into blue or red. Let's do that. Up. This is some monster I'm doing. It's quite enjoyable to do monsters. Personally, I like a lot monsters. But an interesting thing with monsters like that is those are highly readable, and you can explain things way more easier with that. Let's go up so we don't touch anything. So now we have all gates that are powered on, powered to, let's say. Okay, that should do it. What if I'm just trying to validate this blindly? I trust it. I think it will work for first try. So for the dramatic effect, what you can do is you can pop out windows like that. Those windows are not impacted by the switch of hide and show element of UI elements. So you can just keep what you want to keep, and then you can just remove everything else. And the U key is the shortcut to start the validation. So I will just start. So it's turn off the color segments and it starts the validation. And we have our first error here. So it seems like my AND gate, which is here, this one is not plugged to the output of the XOR. So, I need this to go over. So let's just do that simply. I'll just add this line like so, and it should work. Let's try again. Okay. So let's keep that a little bit smaller. U 1, 2. Oh, it should work really perfectly. Okay. We have something that is working. So this is not exactly the naive solution. It is the naive solution in the way that all naive solutions use the schematic that is provided, and naive solutions use get level logic, Boolean logic, but you can use transistor logic if you want to. And I don't know if you looked this specific metric, but you have the MOS, which is the transistor, so the count of transistor there is, and the naive solution has 82 transistor, which is mostly what I have right now. And you can see you can lower that number quite a lot. So I will just do one optimization and then I will close the video here because it's already a long video. But if we go back here, you can see that you have some room to improve this design. So for example, a really easy thing to optimize is here you have this OR gates, which is just there, and there is a NOT. What we can do is just replace that OR NOT by NOR gates, and they will do exactly the same. So if you look at this OR closer, you can see that this section is actually an NOR gate, and this section, so you have like this output, which is the output of the NOR, and the output goes into that, what is basically an inverter, so just two transistors, and then just plug to the power lines. So you have these power lines here, which goes everywhere, and you have this ground power line that is just there. So what we can do is just we hold and select. So we draw a rectangle, a selection rectangle, and then when you have the base, you hit Control and you go up, so you can extrude that selection, and now we can just remove that. Obviously those were fused moss, so what you can do is just remove a little bit left or just redraw what was missing. So I don't need this power line anymore, and just oh yeah, I need, oh, you know what, let's just do the other way around. I will just select this and then like that, remove that. So now we have a NOR gate, and we can just remove everything that is connected to it. So this this as well, and then we connect the output, and it should work the same now. Great. Also, a cool feature you could use, sometimes it's more efficient than some other time. Here it's kind of anecdotal, but if you select a segment, it will select everything, but you can just remove that little block, and now you have two segments. You select and you remove, so it will avoid. So you could have just do a selection, but if, let's say, I don't know, you want to remove this entire right section, you just cut here, and then you can remove everything connected to it. So it can be really handy to remove a line you just drew that was not useful. So let's try to validate that, and I think I will stop the video there with this validation done. So yeah, that's basically what is the naive solution of the 2-bit subtract for this Open Community Gauntlet week 0, and that should be showing up soon enough. So this will refresh every 5 minutes or so. So if you take a look at this leaderboard sometime soon, you will see me. Thank you for following this video, and we'll see each other next week for the naive solution for the second week of this Open Community Gauntlet. Bye!